Hey everyone. Today I'll be showing you how you can create four-player chess inside Unity using AI. So the game I have here is that four-player chess, an example. So here I'm moving the pieces, and as I move the pieces, the board rotates so that the next player can play. So this is sort of like a fully local multiplayer turn-based four-player chess game. There's still a couple of pieces missing, but I'll dive into those as we carry on with showing you how this is done. Let me just make a couple more moves. Move this one here. Clicking is still hard. But yeah, you can get the gist of it from seeing those first few moves. All right. So what I'll do in this video is essentially flip between this Unity project I have here and the video recording of how I created this using Coplay. And I'll be playing back that video at double the speed and skipping over a few parts just to save on time. But just as a quick overview, this is the Coplay agent or helper product that sits inside Unity. And this is essentially like any other chat thread you'd have with AI. Obviously, the big difference is it has full level access to your project and has a lot of tools and fine tuning for games specifically. So the two modes that we'll use in this session are normal and orchestrator. So normal is what it says on the box. It's what you should be using most of the time. And then orchestrator mode will take anything that you have inside this Coplay plan file, this one here, and execute those tasks using child agents or sub agents. And then the two models that we'll be using will be GPT-5 for the planning phase and then GPT-4 Sonnet and thinking for the execution phases. That's just what we found to work the best with our testing, so that's what I use here. Okay, so let's hop to the creation video and kick this off. So this first bit, I essentially ask it, or I was unsure what the layout of the board should be for four-player chess, so I ask it to search the web and essentially tell me what the layout should be. So this is GPT-5 doing some web search work for us. And I'll carry on here until it gives us some output. So it basically says, typically it's 8x8, but for four-player you add three more rows, and then you get a 14x14. And now to continue from here, I wanted it to create a task list that we can then put into our Coplay plan file. And here I specify a few different things for this task list. So I basically say we'll use primitives. I don't want to create the 3D objects right now, although this is something Coplay can also do for you. We plug into, for example, Meshi or Hunyan, any of those API providers for creating 3D models. And one thing that I do tell the model quite a bit is I wanted to create all of the objects and things that we're going to use in the game inside the scene and not at runtime, because this makes it easier for me to edit visually afterwards. I don't want to have to like figure out what's happening in scripts to edit the placement of some of the pieces, for example. I don't want it to also ask it not to write any tests. The models automatically sort of try to write tests sometimes, and that doesn't always work too well inside Unity. We are working on making that better, but for now, I'll manually do the tests and then feed back the results to the model. Let me pause here while I do the rest. We don't need any UI for now. I'll keep this very simple, but we should have a solid approach for like moving the pieces. I want that to feel nice. And then I also don't want any multiplayer networking, just to keep this example simple. So essentially just make it four-player local and we each take turns. And so here is what GPT-5 came up with, all these different tasks. Now to me, I'll carry on playing here. This wasn't ideal because for the orchestrator mode, actually what you want to do is group different types of tasks together so that you can feed all of those to a sub-agent. It can execute all of those with the same level and types of context in one thread. So what I do here is ask it to overwrite the Coplay plan file, and it does that. And cool, I'll actually open this file. So here I open the file, and I'm just going to make a couple of manual edits because I know, for example, I'll just group all of the similar tasks together so that we can feed all of those as one single task to the sub-agent. So here I basically group all the initial stuff, so creating, for example, the board, adding the colliders to the board, then I think the second grouping will be revolving around the pieces. And I can skip over here, just you get the gist of it. Essentially group similar functions together. Again, orchestrator mode here is fairly advanced. It essentially assumes that you have a detailed plan of what you want to execute, and then it'll just follow that plan for you. So here we start with a grouping of the turn manager, the input controller, input system, and I'll skip over a couple of things here. Yes, then some other stuff that I wanted to add to orchestrator mode, or for it to be aware of, is, again, like the thing I said before, I don't want it to create things at runtime, rather just create them in the scene for me to make it easier to edit. And then the last thing I did here was just number the tasks so that it's a bit easier for me and for the model to follow. Cool. So now I switch to orchestrator mode in Coplay and pick Claude 4 and then just hit play on orchestrator. And so what orchestrator does here is it reads that Coplay plan file, finds the first task, and then creates a new subtask. So this is the first subtask, which is essentially create the scene and set up the board. So that's what we'll do here. And again, let me zoom over some things here. So yeah, actually, as part of this setup, it needs to set up the camera, which it did here. So it's sort of top-down view of the board. And it goes ahead, creates the player materials. So we've got red, blue, white, and yellow. It creates a script to create our board. It adds the board. Here it actually ran into some issues. It couldn't find the properties. And then basically these errors get fed back to the model and it corrects itself. It executes a script and voila, we have our 4x4 or 14x14 chessboard. Cool. So it just double checks that it did well. It takes a screenshot. And now we return to orchestrator mode. And this will confirm in our task list that this first task has been completed. There you go. So it updates the file. And now it reads the second step. And it'll probably execute and create that second task. Yeah, so here we go. Here's the second task. So the first part of the second task is for it to just get up to speed with what's been done. It tries to figure out the coordinate system of the board because this is part of this task is to create the coordinate system. So it does a few checks. Writes the board map. And now it creates the chess pieces, I believe. Yeah. So one thing I can mention here. So this error we see up here of the piece type being already used inside the namespace, that's because previous tests of mine, I also did in the same project, and I simply moved all of the content there to like an ignore folder. So a lot of those scripts are still existing in this project, which does complicate things a little because now whenever the model tries to create new scripts that sort of make sense, there's a conflict in the namespace. So yeah, just doing things in slightly in like not easy mode for this this demo. Okay, so we're setting up the pieces and placing them in the right spots. So the different squares. And I'll again fast forward here a little, checks for compilers. Cool, so just zooming back there. So this is in play mode. So it does create the pieces in play mode. But as I mentioned before, this is exactly what I don't want. So here the model corrects itself. It figures out that by looking at the hierarchy in edit mode, the pieces aren't there. So it proceeds to essentially change the scripts to do this in edit mode. And there you can see it's created all the pieces in edit mode. You can see them on the left here in the inspector. But unfortunately, let me actually just make this a bit smaller. Unfortunately, they are all bunched together in the middle. So here it takes a screenshot. It does recognize after this that it made a mistake, that they're all bunched together. But then, unfortunately, yeah, it does a couple more checks to figure out why they're all in the middle. It actually gets their position as well. It sees the issue, but unfortunately, it still hallucinates at some point and doesn't fix the issue. Just fast forward here. Okay, yeah. At this point, it sort of thinks it's done, but we can see obviously from the image that it's not done. I've seen this sort of behavior before, so here I just let it continue, even though it incorrectly thinks that it finished the job. But again, here now task 2 is finished, and now we'll go back to Orchestrator, the Orchestrator session, and mark that task as complete and continue to the next one. The idea I had here was I'll let this whole thing finish for it to basically run through all the steps, and then I'll do a small prompt session where we just correct the placement of the pieces. Okay, so this is the third task. And in this third task, what is our task? So yeah, this is the highlighting system of what we select and where we can move. Essentially showing the player what are the legal moves in their with that specific chess piece. So again, it creates our scripts for us. And I'll fast forward here to get to the results. We have some conflicts again in this example with the piece type, which again already exists in our project. But this whole thread just sets up our highlighting system for when we pick the piece and when we want to place the piece. Here I just double check the inspector to see what the model has done there. Okay, and again, now this thread is done, so task 3 is done. And we carry on to task 4. We speed up again. Oh. So starting task 4, here we can see so for task 4, this is the turn manager component. So essentially ensuring each player gets the right turn and how that order develops throughout gameplay. And it's creating the script there. Here, I'll actually show this quickly. So inside Coplay, we also have this custom rules that you can follow. And here I double check my rules, but I see that it's actually filled and I want it to be empty for this example. So I just clear it so that for the next thread, we won't have any automatic rules. Cool, so the model started play mode here just to do some tests, I assume. Yeah, to check if the turn manager works. I think it figures it does. Yeah, it wrote a little test script. I didn't specify in our Coplay plan that it should not do tests. So that's another area that this could have been improved and shortened. Okay, and now the turn manager is complete, so this task is done. Let's go back to the orchestrator mode. Okay, so now task number 5. Cool. And task 5 is to handle the input of the player. So when you click on the piece, it should select that piece and then show you the options of where to move. And then you should be able to click on where you want to move, and then it should move the piece there. So again, at first, it just reads a couple of files to make sure it has all the right context, knows where to start, knows what's missing, and knows what already exists. Here I could see it again created that piece type script, even though it's already in the ignore folder. Yeah, again, just realizing that folder structure can impact the timing of this quite a lot, but this is also a good example of it being able to handle strange, like broken projects in a way. Okay, so it's setting up all the scripts for us. It realizes there's compilation errors, so it removes and fixes the scripts. Okay. Adding some more. Here it tries to test the input system, but I think it did it without actually writing a test. Takes a screenshot, tries to test it again. And here I just changed the view so we can actually see the inspector next to the AI thread. This makes it easier because the AI does quite a lot of changes in our inspector. And here, if we have it open, we can see how it does those changes. Here it tries another test to see if the input manager works. But we had some issue here where it early returned to the orchestrator mode, and now it's basically just retrying that task again. And what it does is it reads all the context to see again what's been completed. And because I've done this before, I know that eventually at the end of this thread, it still didn't quite get it. So I'll fast forward to that point. Essentially, it kept trying to test it itself when it didn't need to. Here it tries again, and it'll fail again. There's a couple of cool stuff that happens in these threads. So for example, it changes the assigned references inside the inspector for the systems that we have in this game. Just trying a couple of different variations to try and get this input system working. Right, here it tries to test again. Okay, and it early failed again. So now what orchestrator mode is going to do is it realizes it's tried this too many times. So it actually just says, okay, cool, let's stop here and mark this one as in progress. And it returns the thread to us. So it says, okay, cool, I've completed these. And now we have these two that are left to do. And so what I do here is I'll actually switch back to normal mode and instead just sort of take the remaining tasks on manually instead of using orchestrator mode for them. So here I tell the model, in the scene, we currently have the pieces set up, but they are also created at runtime. So I don't know if you saw, but when we hit play, you have these in the middle, and then it also creates it at the outside. So I ask it, one, just remove the runtime created pieces, because I'm pretty sure the input systems and highlighting systems are not attached to those. They're attached to the ones that are already in the scene. And then fix the pieces that are already instantiated, just make sure they're placed where they should be for the initial position of the game. So here normal mode goes ahead and it will, yeah, I'll talk to everything it does. So it basically just gets all the information it needs, figures out what's in the project, what's in the scene. So it creates the script to fix the positions. It goes through a couple of iterations and eventually fixes it for us. Yeah, for example, it noticed that this board map reference was not set. Sorry, the board root reference was not set, which meant that whenever you run the script to create the pieces, the position is 000, which was causing this. And essentially all of the scripts tweaking it does here is just to correct that. This is also an interesting thing that happened. So it's a bug in the Coplay system, but essentially we reached the context limit for this model, which shouldn't really happen because I only did a single prompt. And I didn't know exactly how to continue from here. So first I tried to just ask it, hey, continue. And then one issue that I noticed was when I hit continue, it's the message here makes it sound like it doesn't have any context of the previous work. So instead what I did is just create a new thread and ask it to do that fix again. So I'd already removed the script to create the pieces at runtime, but now I need to fix the starting positions. And another thing I did here was I switched to Claude for thinking, because this model will reason a bit more before actually executing everything. And since this is the model struggling a bit, I decided to go with a stronger thinking model. Cool. So again, it quickly gets all of the correct context. It sees that we have the piece fixer scripts, and voila, it executed that script, and the pieces are now in the correct places. It also takes a screenshot, yeah, to just check its own work, and speed up to see what happens next. Okay, and it removed the helper script that it just used. So here I run it to just test what happens, and cool, I can move the red piece, but now when I click on the blue piece, it doesn't show me a valid path. And I did see this earlier in the model's edits. It actually changed the logic from blue going left to blue going right. So here I asked the model, I start a new thread, ask the thinking model why this is wrong. And I sort of hint at, I think it should be moving left instead of right, because I saw this in one of the scripts or one of the model actions earlier in our project. Cool. So I asked the model just to fix this for us. And I just move the inspector to the side. Okay, and it goes through all of our logic. Here it asks me a couple more things that it wants me to test, but I already know the answer, so I'll just tell it it's correct. Its assumptions are correct. Please make the blue move left instead of right. And here, interesting, what I see in its proposed changes, it does change the blue, but it doesn't change the yellow, which is the inverted one. So then, instead of continuing with these tasks, I tell it that I basically give it feedback here that it should fix it for the yellow as well. So that's one of the nice things you can do here is when you turn off auto approve, when you type in the chat box here, that message will be feedback to the model on the current task so that it doesn't just blindly execute. You can actually correct it and say, no, you're doing something wrong. Carry on in this way. Here again, I didn't see the correct result, so I think it actually did yellow but not blue. And then ask it to check itself. And this time when I hit play, okay. There the red moves, and now the blue moves fine as well. And now I just check the other ones. Cool. So it all works. King can move out, and the horse can move out as well. Okay, so all of the rest of the logic seems like it worked well. The one thing that was missing here that I haven't done, and also haven't done by the end, is logic for you to take other pieces. And I'll do that in the next video to add some logic and add some animations when you actually take one of the other player's pieces. Cool, I'll skip over this testing. Okay, so I'm back to Claude for thinking. Okay, and here what I wanted to do was these chess pieces look slightly too similar for me to discern which is the king and queen. So I asked it, I still want to keep everything as primitives, but create something that's slightly more detailed using primitives and use a script to do it. And the model goes, inspects the current items, then creates a script that should create our more detailed pieces. It runs into a couple of errors trying to execute the script, fixes the errors. And voila, here it has the more detailed chess pieces, as you can see there. Cool. And now I think this is the final task that I tackle. Yeah. So what we had before was the camera would view the board and chess pieces from the top, but I would like slightly more action in there. So I wanted the camera to basically look at the current position that I set it in, look at the board from this position, and on each turn, like flip around so that you're on the almost like the shoulder of the current player. So that we see it from the angle in the screenshot, and with each new player's turn, we rotate or pan the camera around the center of the board. Yeah, so I can basically what I just said. And I take a quick screenshot just of that, and I copy paste it into the chat and send this all to the model. Cool. So I've never ever done anything like this with camera controls, so this is also pretty new to me. And essentially, it links it to the turn manager and creates our camera controller for us. You can see it here, added to our main camera in the inspector. And you can actually see that it creates these different colors for the different views that it has as it'll move around the board, which is quite nice. And checks the screenshot. Check its work. And I stop it there and I try it. And yeah, it works well. There's a few things that I still wanted to tweak. So I found it pretty hard to click on the pieces from this angle. So the one thing I did was I increased the height of the camera. So I can just do that in the inspector here. I set it from 8 to 11, I think. Yeah. Change from 8 to 11, just so it's slightly higher, easier to see the pieces from the top and click on them. And then the last thing is I noticed that the colliders for all of the pieces are just pretty standard box colliders, and they could be smaller and thinner. So I ask it to replace the selection collider for all the pieces to a cylinder that is pretty much like half the current width of the box colliders that are on there. So I ask it to do that. It checks out the info of the current box colliders. I wasn't actually sure if it was the box colliders that are responsible for the selection, but Coplay figures it out. And then it writes a script to replace them all with the capsule glider. And cool, when we click on it, you can see there it's a capsule. That's the collider. And then I ran one more test just to make sure the pieces don't fall over, and this actually works. And yeah, the selection was a lot easier this way because it's a thinner piece, so there's less overlap when looking from the side. And you can also see the camera slightly higher from this position. Cool. So that is how to create a game in Unity only using AI and not using your brain. But it's a pretty good way to learn the different things. And one thing you can also do with Coplay is whenever it does something that you don't understand, simply ask it why it did what it did and how it did it or where it did it. We also have, I can show you here, but in our settings, there is a highlight changes option, which I had turned on for this. But essentially what that means is whenever Coplay makes changes in your project, it'll highlight those changes for you so you can see where it's going to do these things. Also within the inspector, if you, for example, if it does edits in the main camera, you can see exactly what it changed. So you can learn that and hopefully use it to do things more complicated next time in the future. And cool, thanks. That's a quick demo, and hopefully I can share more videos soon. But thanks for watching, and have a nice day.